Hello, everyone. I wanted to test first before we start our session. So, can somebody ping me and in the chat and say, can you hear us or can you see us? It's a quick check, please. Attendees, can you hear us? Can somebody type in? Yes, okay. We can hear and see. Oh, great. Thank you. Thank you so much. So I'm starting. Yes, great, great. Hi, everyone. I'm Shravani. Warm welcome to all of you in the webinar interview series, Crypto Innovation. In this series, we interview the Indian startup with innovative ideas in the complex but salient field cryptography. Today is part 2, and the topic is quantum-safe cryptographic approach to secure. Sorry for that. A quantum-safe cryptographic approach to secure messaging. The need of the hour. As millions of people are staying at home during the COVID-19 outbreak, the video conferencing tools such as Zoom, messenger services like WhatsApp is the glue that has held the global community in contact. Nowadays, important and sensitive information is being transferred over the WhatsApp or other messenger services. Zoom data, which has become the default video conferencing medium post the COVID outbreak, continues to face backlash over privacy and security issues. At the start of April, cyber risk assessment firm Cybil discovered that over 500,000 Zoom accounts are being sold on the dark web. The main reason of the Zoom attack was the weak encryption. Considering the current scenario, data theft and privacy are the major issues that need attention. So, do you really think that the current messengers apps are secure? Answer is no. What will be the solution to the current messaging scheme? How can we make our messaging unbreakable and more fearless for the user to share the secrets? Can we make the life of the attacker miserable? To find out the answers to our worries and concerns, we have our guest today, Mr. Kanak Kawadiwale. Mr. Kanak Kawadiwale is the founder and CEO of cyber security venture Arishti Cybertech Private Limited. He founded the company during his early bachelor's in 2018. Kanak is the cybersecurity and artificial intelligence enthusiast with professional experience in cryptographic product development and a quantum cryptographic researcher. Mr. Kanak has contributed at a couple of well-known industries for niche product development, one of like Rubiscape, a Make in India data science product. He is also recognized by the Ministry of Defense, Government of India, and received the Persistent Inspiration Award. He has been honored and appreciated by AICT Startup Committee for Innovative Product Startup. Being a cybersecurity professional, he is also currently pursuing cyber law. His venture is currently developing MIME, Message Me, a hyper-secure messaging application for closed group communication using quantum cryptography and AI. Welcome, Kanak, to our series. As he is a quantum cryptographic researcher, let's first find out about the quantum cryptography. So, Kanak, I would like to know what is quantum cryptography and how it is strong compared to the standard cryptography.
Well, Shravani, thank you for inviting me, first of all, on this webinar, Crypto Innovations, that's being hosted by National Center of Excellence. I'm privileged to be a part of this. So coming down to your question, Shravani, that what is quantum cryptography? So before starting, quantum cryptography, we must have a look at what's quantum computing, like how these things work and how this actual scenario comes into picture. So basically, to be very precise in quantum computing is something, which works on qubits. Now we come up with the question that what's a qubit? So our classical computers, compared to as classical computers, our computers works totally on bits, that's known as binary language, zeros and ones. So, quantum computers have some supreme powers, or maybe, some supreme infrastructure wherein, this zeros and ones come in and they form a qubit. Now, why we call this qubit, So when we talk about quantum computers or quantum cryptography, so these beats are being represented in the forms of qubits, and these qubits have some tendency wherein the superposition, the term named as superposition. So this superposition is something wherein you represent zeros and ones at the same time. So you don't get this actually, yeah. So you don't get actually such kind of powers in the classical computers wherein you use your binary language. That comes up with the with the supremacy of quantum computer. So this is the basic base of working on quantum computing. Now coming down to the next question, that's quantum cryptography. So quantum cryptography is using your cryptographic algorithms or having such kind of cryptographic algorithms which uses the phenomenon or the properties of natural quantum physics to to secure your organizations, to secure your data, to secure anything that comes in the picture. Now when we talk about quantum cryptography, so quantum cryptography is it's a very broader concept, and it's a totally research area today wherein many scholars and many cryptographic communities are diving into this to understand the importance and to understand the working of this quantum cryptography. So this is what actually the quantum cryptography is, wherein you work on qubits to make the things more secure, more secrecy to maintain about your information, and to understand the level of secrecy that an enterprise or that an organization has to maintain. So this is about the quantum cryptography.
So do you mean to say that the structure of the qubits are different than our classic computers, right?
Yeah, right, exactly. So when we talk about this qubit, as I said, they have some natural tendency, or we can say as a superposition. There's a term named as entanglement. So this terms itself defines the qubits. So qubits, there is none of the phenomenon wherein you can represent zeros and ones at one state. That can be done by quantum computers.
Yeah. So it's quite different that you can represent 0 and 1 at the same time.
Exactly.
Yeah.
Right.
So that's really,
that's the supremacy of quantum computers.
Quantum computer. So when we talk about the quantum cryptography, can you tell me what are the different applications of the quantum cryptography? So what are the different applications?
Yeah. So when we talk about the applications, so there has been a lot of research, Shravani, in quantum computing, and actually there have been many applications in industries that are working. So to name few of them is first of all is a cyber security, wherein we use many cryptographic algorithms to maintain or to strengthen our systems, to strengthen our crypto applications. The second that comes in the picture is what comes in my mind is recently TensorFlow has come up with its own quantum machine learning libraries. So even in artificial intelligence area, quantum computing is growing and it's increasing. Now when we talk about this in artificial intelligence sense, so why do we need this? So this is the basic necessity, because researchers in this field of artificial intelligence, in chemical industries, in automobiles, or in blockchain, even in blockchain, so these people think that the mechanics that quantum computer use is amazing, and so these applications are ever increasing. These are not just restricted to what I said. There are much more again on this. So recently China has come up with the quantum encrypted video calls. So that's the most important thing that's coming up in market and in enterprises. Also to mention about Switzerland is using a smart quantum cards to maintain their identity. So as that we have Aadhaar cards, they have smart cards with quantum encryption. So that's great. It's ever growing and increasing in the space of security, as well as in the research field of physics, chemistry, and much more.
So that means it is spread everywhere. So we cannot just say that it will be limited to this particular area or that particular area. It is, I think, entering in every field, every aspect of life, and it is going to affect a lot. So we can say that with the quantum cryptography, our systems will be more stronger. You can say
Yeah,
that.
more stronger. Yeah, exactly. More stronger and more safe in the terms of cyber security, and in the terms of computation power, in the terms of efficiency and performance as well.
Great. So I'm just wondering, like, when we are talking about the quantum cryptography with this new terms, we are discussing qubits and, so do we really need the different, like, quantum computers or a hardware to run these algorithms, or how we are going to do that?
Yeah, so see, when it comes to quantum computers, there's generally a hardware requirement that comes into picture. But when we talk about this in the sense of having us own quantum computers, or there are many types of quantum computers wherein you use these quantum computers as an API. So this is a system wherein an organization or a government can have their own quantum computers, enterprises can have own computers, and it's basically a hardware architecture. It needs a lot of performance capabilities, efficiencies, and this all kind of infrastructure it does need. So but that doesn't mean that it cannot be used by the general people or citizens of any country. They have this kind of machines. So yes, there is actually the need of hardware wherever you talk about quantum, but also there is other side of this wherein you can have your applications working on this APIs being provided by the quantum computer holders.
Okay, great. So yeah. When we talk about it's a new technology, right? Like very new field and quantum. So what are the myths you find in this quantum cryptography?
Right. So recently I was in a meeting, and that was a meeting with my colleagues only. So one of my friend, she was not knowing everything about how this quantum works, and I just say that quantum computers are going to change the scenario of digital world. So she was like, she asked me the questions that will classical computers be replaced by the quantum computers. So this is the major questions that comes into everyone's mind, that when this quantum yeah, so when quantum computers come into picture, or when this quantum supremacy comes in picture, so the answer is absolutely no.
Okay.
The architecture of when any kind of quantum computers or quantum supremacy comes in, so classical computers won't go up. It would be a hybrid kind of architecture. So hybrid, when I talk about hybrid kind of architecture, it would be basically like you'll be having your own systems or your own machines itself, but there will be enablement wherein you can you send your parameters, you send your data to the nearest or the quantum computers which is available, and you put forth your data to that machine and fetch the results out to your classical computers. So so this is how the scenario would be when quantum computers come into picture and it comes into public life actually. So
Okay.
won't go off.
Okay, great. So what are the different types of quantum cryptography? Are they same like symmetric key and asymmetric key, that what we talk in modern cryptographic schemes, or they will be completely different, what it is? Oh, just a minute, Kanak. I just wanted to quickly ask audience, can you hear us? Some are facing problem. So can you hear us? Okay, great. So yeah, go ahead. Yeah, please.
Yeah, right. Okay, cool. So talking about the encryption algorithms in quantum supremacy or in the quantum era. So yeah, there are actually multiple types of encryption algorithms or cryptographic algorithms. Unlike the things like what we talk in the today's world about public key infrastructure and the secret key encryption algorithms. So there are also these algorithms are also there in the quantum phase when we talk about quantum secrecy. So one of the type which I would like to mention, and which is world famous and very good in the researchers community in quantum computing, is NTRU. So this NTRU algorithm, this algorithm is too much like famous and have gained a lot of fame in the quantum researchers in the public community. So when we talk about this NTRU algorithm, it's basically like a public key infrastructure wherein you have private and public keys. But now what comes in the picture when we talk about this NTRU algorithm is it consists of basically two functions. That's NTRU encrypt and NTRU sign. So it's basically if you understand and if you take if you consider this, it's a basically like digital signature plus encryption.
Oh, yes.
So
Yes,
authentic encryption that we talk about in the NTRU. So this is a public key infrastructure in quantum sense. The next that we talk about is quantum supremacy key resistance. So when we talk about this quantum symmetric quantum key resistance, here you use the traditional algorithm also known as AES. So AES 256 is still a part of research for the researchers in many universities, that quantum computers have not yet found the possible ways to come up and to break the AES algorithms. But
okay.
so there are some conventions in this that I want to talk. So AES, when we talk about, there are many encryption modes that we crypto community as basic need to understand, that which mode do we use in this encryption algorithms like AES. So what have come up with this research, so AES GCM provides the much more powerful encryption in the sense of quantum resistant algorithms. Now second
Okay.
thing, this comes is the key generation process in this symmetric key resistant key encryption algorithms. So this is a very important thing that you must pay your good attention towards the key generation process, even if AES seems to be quantum resistant in this phase. So these are the basic two. Apart from this, there are many like like hash based, code based, and multiple kind of encryption algorithms. So it's a diverse field wherein there are multiple, not restricted to symmetric and asymmetric just.
Okay, so it will fulfill what we need it right now, like just like a symmetric key algorithm. Also, it can provide us the public key and also the hash function. So
Right,
it can
right.
completely replace the conventional or modern cryptography. We can say that
Yeah,
because it is
it's
fast,
going to
as you
soon
are saying.
replace. Yeah, it's going to soon replace each and every the algorithms, mainly the public key infrastructure that is being used currently. When we talk, we'll come up with the some of these examples in our slides.
Sure, sure. So I would like to, bring the attention about the Indian government. The Indian government
Yeah,
announced that it is planning to invest 8,000 crores, that is approximately 1.12 billion, in quantum computing research over 5 years. I mean, it's a huge investment.
yeah.
And yeah, so would you like to put some light on it? Like what kind of research they are expecting? Will it be just cryptographic applications, or will it be cryptanalysis, or yeah, so that like I want to know more about it.
Yeah. So it's a very important thing that I would like to and appreciate Indian government in coming up with such kind of initiative wherein you propose 8,000 crores of budget only just for the quantum
Yeah,
computing research. So the main reason behind allocating this budget for the quantum computing is just to get in the traction period wherein multiple countries are actually working on this, and they are very ahead of this. So we don't want our systems and our infrastructure to lag behind. So we are equally
correct.
going ahead, and this is where India is putting its putting its leg ahead in this and going towards Atmanirbhar Bharat. That's the
Yes,
very
I'm
important.
coming to that. Atmanirbhar Bharat, right? So it's
Yeah,
like
yeah, yeah.
it's a huge thing. I mean, India is investing quite a good amount of money in quantum, and
Yeah,
quantum is now people are saying it will be the future. So yeah,
exactly.
so and I think I was like, people like you are investing their time and energy and finding out different things in quantum is really a good thing. So yes, India will be soon Atmanirbhar. So
Yeah, exactly.
I yeah, so let's go to our topic of like messaging schemes. So,
Yeah.
what do you think? What like there are several messaging schemes. We have recently heard about the Zoom attack, and so what do you think? What are the problems in the current messaging schemes? Are they susceptible to quantum supremacy?
Yeah, so amazing question. Thank you. So, is my slide visible to you, Shravani? Can you just?
Let me. No, not yet. So I would request audience, please ask your questions, and let's make this uh, session interactive. So I would like to take your questions to Kanak, and it'll be great if you'll ask. Yeah,
So,
your
is my slide?
slides are visible. Yes, yes, your
Okay,
slides are visible, right?
okay, great. So, yeah. So now, Shravani, as you asked me about like what are the problems and what are the leakages and what are the problems overall when we talk about the messaging applications. So the first thing that we talk about is the weak encryptions. So as you mentioned in the introduction, the Zoom came up with its own video
Correct.
video calling application, but soon within few months we can say it came up with many objections that how this that the data of users is being sold on the dark net and dark web all over there. So one thing that I
Right,
came
right.
up with this application was that Zoom was using AES encryption with the ECB mode, and
Okay.
in this cryptographic community, we are very much aware that using ECB mode is the most not recommended in this
Right,
today.
right. Not
So
correct,
like
correct.
when we have this kind of application, we must have a sense of responsibility that what kind of products are we building and what kind of security are we providing to this applications. So first
Correct.
thing I would like to mention here is the weak encryptions that takes place in any kind of applications today. The second
Right.
the second thing is lack of biometric identification. So
Mm-hmm.
when to identity management, identity access. So there has to be certain kind of a biometric verification where you have users identity, that is a unique identity, and you give them access on the basis of their biometric identification. So this is the second thing that many of applications don't have, and they don't pay much more attention towards this biometric identification systems. Now,
Correct.
what I'd like to also mention here is recently in India, RBI has come up with the some kind of biometric systems for onboarding. I've recently heard about this. So when we talk about these systems, there are some problems even in implementing such kind of biometric authentications. So those are like there are spoof attacks that are happening all around the world, and this spoof attacks is the most vulnerable kind of thing when you use identification in biometric sense. So this is where there lies a problem even if you use the biometric identification. Then next comes
Okay.
is of GDPR compliant products. Now when we talk about this GDPR compliant products, so GDPR mainly talks about like how your product is providing providing or maintaining the users secrecy, users privacy, and how people use this application to make sure that their data is not getting leaked or their data is not getting sold somewhere else. So this is what
Yeah.
the problem the messengers coming up next. So now next coming down to this is uncontrolled data. Now I would like to grab your attention to the red line that I have on the slide. So it talks about
Mm-hmm.
Cambridge Analytica bragged that it had up to 5,000 data points on every US voter. Now this is something huge. Like each voters every private data and everything. So Cambridge Analytica is one of the analytics company which had 5,000 data points on each user. So you can just imagine
Okay.
that if they have our so sensitive data, that when do we wake up, when we sleep, what we do, this kind of each and every data point they had, and they changed this and they used this kind of data in turning out the electoral process and electoral elections, and that too happened. So this is the kind of uncontrolled data where you don't have any control of what you are using, what are you sharing, what are you doing. So this is the uncontrolled data. Also, I would like to take one of the examples here is like recently came up in New Delhi, I guess. So that was like boys' lockers room. It's a very important thing that when this content got shared, so where was the privacy? How did this happen? And there comes many questions that how these things happened using this technology. So we need to pay attention that what content is being shared on this kind of application, chat applications, or
Correct.
any application. So this is the responsibility of the product developer or the organizations, that when you develop such kind of applications, you must have a sense that none of the users loses his privacy or his secrecy. So these are the basic, these are the basic things that are very important in the today's world of messaging.
Right. So can you a little bit talk about uncontrolled data? I'm not pretty sure about if I.
Yeah, right. So when we talk about uncontrolled data more, so to deep dive into this uncontrolled data, so when we share any kind of contents, so there are no kind of provisions that whatever you share with your friends, with your colleagues, with your anyone. So when you share this kind of information, you must know that whatever content you are sharing is a legit content. So when you share this
Okay.
kind with anyone, you must have that sense of responsibility. And if that is being hampered, so there comes the uncontrolled data that happened recently in many kind of situations. So uncontrolled data is like you just keep on sharing. There is no one to keep an eye on your content that is being shared, that is hampering someone's privacy or users. So coming down to this uncontrolled data, there is a process. There has to be a process wherein when you share any kind of data or any kind of multimedia sharing, so that has to be analyzed. So that analysis is to be done on the basis of what are you sharing. Is that actually good to share, or is it just that it's not a legit and it would create some kind of rumor in the society. So this is what
Correct.
uncontrolled data means in the sense of social media.
Okay. Okay.
Yeah.
So there are some problems, like many problems you have pointed out. So what is the solution? That is like problems to identify,
Yeah,
but we should know about the solution, right? So what do
yeah,
you think?
right.
What is the
Yeah. So coming down to this solution, before coming down to this solution, I just want to grab the attention of users and audience. Like you're seeing my screen, right? Is it visible?
Yes, yes.
Okay, great. So I just want to grab your attention on this slide. It's very important that these are the two phases that I've created in this. So the first phase talks about store it now, and the second one talks about decrypt it later. Now just we'll go within the slide within a minute. So store it now is a phase wherein many spy agencies and many attackers are trying to collect the data, and they are not just trying to attack the systems right now. They are just trying to collect the data whatever they get, may it be in the encrypted format, may plain text format, whatever it may be. So they will just collect all the data that they get, and the messenger is the most important and most vulnerable thing that they are targeting. I'm talking
Okay.
about the spy agencies or the attackers. Now when this quantum era comes into picture, or when there is period that they get access to the quantum computers, they'll decrypt it. Now how do they do this? Now there's a algorithm which talks about getting down or breaking down the systems. So we should talk about the Shor's algorithm. Though
Okay.
Shor's algorithm, so Shor's algorithm is something which can give you the factors of a long integer within a fraction of seconds. So
Correct.
this is the most important thing, that once you get and once you collect all the encrypted data or whatever the traffic that's going on in the current scenario on internet, you'll apply the Shor's algorithm to to retain those keys. Now once you apply the Shor's algorithm on this data, you'll find the encryption keys that's being used by this all the data that is being transferred on the social media, or maybe say messengers. And once they get all this access to the encryption keys, there will be an unimaginable speed where your secret data and national security agency data, all this data will be leaked within fraction of seconds, and this is going to happen. This is going to happen very, very short in the time of period.
Yeah, so it's scary.
Yeah, it's actually it's very scary. Now now when we talk about this these systems that are being built up, so I would like to mention this. Now when you see this slide that I've shared, so when we talk about the encryption decryption, you perfectly talk about secrecy and confidentiality of your data. Next, when you talk
Correct.
about the authentication, you talk about the identity management of the users. And when you talk about the digital signatures, you talk something about non-repudiation, that whatever you have sent is yours, that is your set.
Right.
The last one is the session tokens, one-time codes, etc. Now when you see and when you have the bird's eye view on this slide, you will get to know that this is the only thing that cybersecurity works on. So cybersecurity revolves all around these all things that come into picture, and these all
Correct.
things, these all things are some or how related to the random number generators.
Okay.
This is what I wanted to grab the attention, that the random number generator is the foundation of any crypto systems that we build.
Right.
Now I just wanted to share one more story that I recently came up with, that in 1995 the New York Times gave that article that one of the company built some web application, and after coming to that web application, some of the researchers in the field of cryptography from University of California, they just reverse engineered their this web application code, and what they got to know was really shocking, that the seed generation, or the random generation, was totally based on the day timings. So they got to about, so this kind of vulnerable things is very susceptible to the even to the classical computers. We don't need to go into a quantum phase.
Correct.
So when you when you get to know about this, that the seeds or the quantum number generation is based on daytime, so the whole scenario is like you have got it, and you have known the system very well, and there is a lot of things that you can apply on the systems to break it down easily. So this is where this kind of systems have very much problems in developing such kind of crypto systems. Now when we talk about generation, I just wanted to point out that what are the currently being used random number generators. So these are the few random number generators, like true random generators, pseudo random generators, and hybrid. So talking about this random number generations, people use this very, very fluently, and they are very comfortable with this. But what we need to know and what we need to understand about this random number generation is that these are somehow basically associated with some mathematical foundation or mathematical base. Now when it comes to see this mathematical algorithms, as I talked before about the Shor's algorithm. So Shor's algorithm is one which can break this down, and it can factorize all these mathematical components, mathematical algorithms, and come up with the solutions, or come up with this retaining the keys whatever are being generated by true random number generator or pseudo random generators. So when we talk about this, these are the probable random keys. Now when we talk about probable random keys, these are not the cryptographically safe. That's what we see. Now when we come to this, now let's go to this. Here's the solution that we talk about. Sorry for the long slides that I've come up with. So so there is a quantum random number generator. So when we talk about quantum random number generator, this is the slide itself says that it's the true entropy. So when we talk about information entropy, the true entropy means that it's totally unique in the nature, and it cannot be retained. So the basis of quantum random number generator is basically on the quantum physics that I talked about previously. So when we talk about this regeneration process in the quantum random number generator, so there are multiple things, and there are a few steps that we must go through, and that a quantum computer goes through. So first one is the quantum basis. So whatever we generate or whatever the random numbers are being generated by the quantum random number generator, it totally comes up from the quantum basis. That means it's formed on the basis of qubits, not on the base of bits. So here
Right.
itself it proves that it's somewhere naturally random, and it's a provable random thing. Now once you get this quantum basis, and once you generate this qubits in the quantum computer, the quantum computers typecast the quantum basis or the qubits into the stronger and the larger key generation. Now you just cannot use the random qubits to generate the keys. You need some process to you need some process to get this quantum bits or qubits into the larger, stronger keys. So these keys are generated by the quantum computers, and then you use this kind of key generation for the quantum resistant or the safe systems. Now when you use this kind of quantum random number generators in your application, or in any kind of sense where the cryptography comes in picture, this is the most safe kind of process, or maybe we can say a process or function wherein you can get a good kind of or true entropy based random numbers. And this is the base where the encryption proves to be stronger. Now when we see that any attacker talks about the attacking any kind of system or does attack in any system, they don't really talk about, or they don't really attack on the encryption part. They attack on the keys. So this is where the key is most important part. So this process has to be very, very niche and very efficient in the terms of security and in the terms of entropy. So this is how we come up with the provable random keys. This is known as a random provable keys.
So can we use this random number, which is a key, to our current schemes, or we cannot use it?
So yeah, so actually, as I said, that there are couple of options that you can do. So absolutely, you can use this kind of random number generators. And even to be precise and to be accurate on this question, IBM Qiskit computers are providing much more APIs which you can use to to get this kind of systems and to integrate this somehow in your application. But you need to understand that where is the importance of using this quantum random generators. You just can't use it. You just can't use it just because the sake of you want to use it. You need to have a sense that where you want to use it actually. So that's the way. So yeah, surely you can use quantum random generators today.
Okay. So you mean to say it is truly random, right? Not the pseudo random.
Yeah, it's a provable random, not a probable random.
Probable random. Correct. Wow.
Yeah.
Okay. So audience, do you have any questions? Please ask if you have any questions. Yeah, we will wait. Okay. So moving forward, like how can we use it? So it will be definitely used in the quantum cryptographic application and also in the conventional, as you say, but we have to see the application, right?
Right.
Right, correct. Okay.
Oh, yeah. So now coming down to the products that that Arishti is building. So I would like to grab the attention audience to this. So we are actually building a hyper secure messaging application for closed group communication. Now when we talk about closed group communication, I just want to give a base that why and how are we building this application. So basically, when we talk about closed group communication, it has to be or in the nature it has to be very sensitive, it has to be very private, and it has to be it has to be authenticated communication. So while coming down to this application, we thought about the open community applications that are being used by current organizations or enterprises, which have already proved to be a vulnerable thing for the communication. And hence we came up with a solution that's known as me. So it's a basically message me, that's me. So we have come up with the solutions wherein, as we discussed about the quantum encryptions or quantum random number generators. So we are coming down with this application, and we are in the beta phase in this. So we are using, so we are basically using quantum resistant key generation in this application, which has a tremendous lot of tremendous, true entropy that we talked about previously. The hashes that we talk about now, coming down to this hashes, hash is the most important part when you talk about hashing some kind of information, like mostly passwords. So we have used the script type of password hashing here. So this is basically, script is basically a password hashing function, and to be precise, it's a memory hard function that we have used. uh, more to talk on this script is basically like when you talk about script functions, it's a memory hard function wherein you can't just keep on guessing or using your rainbow table attacks. So this is the most important part of using script hashes. So you can't just keep on guessing with the help of rainbow attacks. So that's where the strong hashes come in picture, like a script. Now coming down to the next thing that we have used is the 3D face authentication and content analysis. Now, as we said that the uncontrolled data and the authentication part. So we have used 3D face spoof resistant authentication for the users, and we have used certain kind of algorithms to understand what kind of data is being shared. Now when we talk about the data being shared in this world, so once you, as this application is end-to-end encryption, once the data goes out from the device and goes into the network, you don't have any chance of analyzing the database, because the whole data is encrypted, and you cannot analyze the encrypted data at this part. So you have to analyze what is being shared at the endpoints, what at the center point. So we here at Arishti are developing such algorithms, and have developed such algorithms which provides to analyze the contents what is being shared. This is basically like you'll have to first understand that whether you are not sharing such content which would create a rumor in the society, or which would encourage the child pornography or anything that comes up into the picture. So this is the basic thing that this is the most important thing that we came up in this application. And latter one is the GDPR compliant product. Now this is a very diverse field when we talk about the GDPR compliant products. And so when coming down to these products, you must have a sense that when you are hosting your application, as this is a made in India product that we are coming up with, so we want we want this product to be a product which can follow the processes, or the GDPR compliant policies that government have come up with. So this is the main motive, that this kind of application must be able to provide provision wherein people can, or wherein like cyber crimes and any kind of crime can happen, and this application is able to provide some information to the audience or to the public or at any places. So this is how the general scenario of application that we have come up with. Now I just want to highlight one part in this is the 3D face authentication, or we can say as a biometric anti-spoofing systems. Now when we talk about this anti-spoofing techniques, so we have come up with this kind of solution which proves to be detect this kind of attacks and overcome these attacks. So basically whatever attacks that happen on biometric systems are generally the replay attacks, the 3D spoof attacks, and the Cassia surf attacks. So these attacks have proved to be the most dangerous in the world of authentication, or maybe say biometric authentication. So we are using some innovative kind of technology which consists of a blind image quality evaluator. In this, we are trying to extract certain features. So basically, there are 21 data points out of each image that we get for the application, and we extract near about 21 features from this photo. And this 21 features help next us to analyze the effective pixel similarity deviation. Now, when we use this 21 features out of this image, we have this kind of algorithm known as effective pixel similarity deviation helps us to identify whether the image is a live image, or it's a spoofed image, or is it a 3D spoofed, or is it a 2D spoof. So this kind of system that we're coming up in this product. And this product talks about something like guessing the liveness of a user's presence. So even if the user is only if the user is present in front of his or her application, only then give them the access, and not in the case of where virtually someone is trying to provide your picture, or trying to provide your biometric identification systems, and then trying to get the access to this. So we are trying to overcome this kind of attacks in these systems.
So it's mix of AI and machine learning and cryptography, quantum cryptography.
Yeah, right. So yeah, so in this world we must put our highlight on the dark systems. Now when we talk about the dark systems, this is like DARQ. So there has to be some decentralization. And when we talk about artificial intelligence and the realities, that is like virtual reality, augmented reality, and the next comes is Q, that is known as quantum supremacy, or quantum cryptography. So this is the phase when we should towards the dark system or dark applications. So this is the right time we should consider using this kind of technology, which is already advancing in every stage of technology and every stage of enterprises and organizations.
Correct. So Kanak, I would like to pause a bit, and there are great response from the audience, and they're asking a lot of questions. So I'm happy that they're asking the questions. So can we take a couple of the questions?
Sure.
Yeah. So Mayank has asked, what is the fundamental meaning of being quantum safe? Whether my algorithm is safe against any X qubit quantum computer of today, or is it safe against a future quantum computer in which qubits will scale?
Okay, right. It's a great question. Thank you, Mike, for this question. Actually, so when we talk about the quantum safe encryption algorithms, so we mostly talk about the qubits, or the encryption algorithms that have been used in the sense of using qubit supremacy. That's a quantum bits supremacy. So whatever we talked recently regarding the quantum random number generators and the algorithms that are being used. So when you say about the quantum safe cryptographic algorithms, so whatever we do in this application, so it's about like it's a quantum safe approach towards quantum supremacy. So whenever in the latter stage, as I mentioned in the second slide, that when there will be a quantum supremacy, or there will be quantum computers in the picture, so that all the key generations that we have done till the date will come down within a fraction of seconds. Now this is the phase where you will not survive using just whatever we are using currently. So you have to be quantum safe, and that's the where we are becoming quantum safe using the quantum random number generations. So that even if you attack these quantum number generations, there is no mathematical background that comes up in the picture. There's some quantum physics that comes in the picture.
Oh, great. Thank you. So there is one more question by Sanchali. Want to know how quantum and IoT work?
Oh, that's amazing. That's amazing. So yeah. So recently, I've been a part of one webinar that was totally focused on using quantum computing in the IoT systems. Now, when I did talk about this IoT systems, so IoT systems are, this is the most vulnerable part in the ecosystem, because each and every device is generally connected and normally connected to the internet, which spreads all the data across. Now, when you talk about this connected devices, you have much more sensible and much more responsibility to maintain the secrecy of whatever data or whatever the coordinates or the parameters that you are sending to these to this embedded systems. So when you use this IoT systems and you want to use quantum computing, So the most important part comes into picture is the quantum random number generation. So basically, quantum random number generation is the most important thing that you must try to integrate in the IoT systems, wherein people are trying to verify your devices, wherein people are trying to use your devices. So you have to use such kind of systems wherein this kind of identification, this kind of encryption and decryption of the process works and goes through the quantum phase. So you'll have to use this kind of systems to in the IoT. So yes, basically you can like there is a much more scope in the IoT for quantum cryptography.
Oh, great to know that. Hope, Sanchali, you got your answer. And there's one more question by Viral. With quantum encryption, will the hardware change? The routine hardware.
No,
Hardware will change.
I didn't get the question actually. What do you mean by hardware will change? Which kind of hardware you're talking about? So see, when it comes to quantum computing, the hardware will be the same that comes in the quantum computers. You don't have to change your hardware. So what you can do is there are two options, as I said. So thank you for this question. Actually, I can come up to the second device that earlier previously the Samsung came up with the quantum chip actually. So this quantum chip is actually inbuilt in the Samsung's mobile, and it uses the quantum random number generators. So yeah, so coming down to this question, the hardware does not change actually. So it's like you have built one infrastructure like a quantum computer, and you use this quantum computers maybe in the process in the phase of APIs or in direct sense, and you just provide your parameters and your data, and you fetch the results. So you can't actually keep on changing your hardware of the device. I hope that makes sense, and I've answered that question.
So one more similar question by Kamal is, does quantum cryptography require quantum computer for processing? I mean, it's like common
Yeah.
questions that are coming.
So can you repeat the question, please, Shravani?
Yeah, does quantum cryptography require quantum computer for processing? I think we have covered it, yeah, but you can repeat it better. If you want, you can just. So there is one more question.
I'll come back to the same thing that it's a situation wherein if you have a direct access to the quantum computers, it's great. If it is not, then there are multiple researchers who are actually using these quantum computers in the sense of APIs that is being provided by the quantum computer owners or maybe government organization or research institutes. So that's the question. Yeah, that's the answer.
So Srinivas has asked something. Hi Kanak, most of the quantum cryptography today is using key generation. Are today's encryptor good? We only talk about hybrid solution.
So yeah, like when we talk about this hybrid things, so when do we talk like what do he mean to say in the random number generation or in the process of other things, like hybrid in what sense?
So Srinivas, can you please repeat the question so that he can answer? Like it's not clear. So we will take next question by Kamal. What amount of CPU power do you propose for quantum cryptographic encryption?
So yeah, talking about see there is no such kind of thing wherein you will have, or just we can provide the parameters or the digits wherein you need the quantum performance or quantum supremacy to be applicable on your classical system. It's still in the research phase wherein people are researching in how they can integrate these kind of things in the classical computers and not just using it at a big scale. So it should be used by a regular person like us in the classical computers, and the parameters are not yet so I cannot just throw out like what kind of efficiency or what kind of things will need. But yes, in this regards there will be much more advancement in the specialization of your cores of your computer that comes up, because when we talk about quantum things, it needs large of actually needs much of efficiency for your computers to actually accept the results that are actually getting fetched from the quantum computers.
So does quantum is a only latest secure technology in security? If yes, how India and related sectors are adopting it? It's Akhilesh wants to ask.
So yeah, so when we talk about security, so we majorly talk about the post-quantum security or just quantum safe security. So it's not the thing that it is the only thing that will make security, but it is the most viable solution in the current phase, wherein if you use this quantum supremacy and use the quantum cryptography technologies in your applications, you will be safe in the regards of in the future regards. So this is the basic thing that will give you the assurance to be safe in the coming future. It will not affect directly in the current situation, but it will surely affect in the future.
Okay, so Prashant wants to ask which vendor are providing QRNGs that speaker is using.
Yeah, so basically there are a couple of things that I would like to mention in this. So first is the IBM QuizKit does provide this, and second is ID Quantic.
Okay. Any live example of QRNG? I think you have answered.
Yeah.
My question there. So there is a question from Savan. Uh, this is very informative session from Kanak. And my question to Mr. Kanak is how to start with the quantum computing and quantum cryptography. Also, as mentioned that we can call APIs to perform quantum related coding. Is this free service? How can a student start learning this amazing technology? Okay.
That's a great question. Thank you, Sawan, for this question. Actually, so yeah, actually, it's a freely available with IBM QuizKit. So you can start, coding. It's basically a Python-based language that IBM QuizKit provides, and you can start, or you can just go on searching with the IBM QuizKit. And this is a basically IBM's quantum computer that you can use, and this is basically for the academic purpose as well as the business purpose. So as your as a student, if you want the question, if you want this answer to be precise, you can start with the Python and IBM QuizKit. So this is how you can start, and to know how this quantum computing works, you'll have to gain some knowledge about how these qubits are being generated, how these quantum computers are being manufactured, or how this quantum thing works. And the most important part that I would like to you to grab is the physics behind this quantum, because as you go ahead and ahead of this, so you just can't keep on going into deep of technology. You need some natural base to know how these things and how this quantum cryptography works. So maybe if you can learn about some photons, this is how actually quantum works. So you can get some concepts of photons, and maybe later on you can move to the IBM QuizKit computer, wherein you can directly code if you are techie person. So you can directly code in that computers and you can fetch the results. Also, second thing, if you are artificial intelligence enthusiast and you love to work on AI things, you can try out TensorFlow's quantum machine learning APIs.
Oh, great, great, great. So even I am motivated. I think I should start learning about it. So
Yeah.
let's take another question is, do you use 3D camera for depth sensing for 3D spoof detection? Prashant.
So yeah, so when we talk about this 3D cameras, it is not the situation wherein you just have the 3D camera access to each and every phone, but there are a couple of there are few vendors which provide the 3D cameras to the mobile itself. But we are not focused on to just using 3D cameras. We are focused to the normal cameras which we have, or which any kind of mobile application, mobile phone has. So it can work in both the sense, in the 3D cameras as well as in the one which we are using currently. So basically, when we talk about this camera proposition, so cameras play a very important role, and this is a very important question. So how do we tackle this? I would like to just mention in this. So as I said that we are trying to get 21 features out of this, and this is a very huge this is computing that we are doing in the initial phase of this application. So these are the solutions. Even if you don't have 3D cameras, you can get the feature extraction processes and try to analyze the data and then work on those models to get the liveness.
Great, great. So there is one more question by Mayank. How do we control entropy generation in a unstable system of qubit world, and how can we can validate it is truly random generation and there is no pattern?
So the previously asked question was like which are the vendors provided, which vendors are providing this quantum random number generations. So there are I purposely mentioned about the IBM Qiskit and then the ID Quantic. So they have their own this quantum random number generators initiated and developed. And when you make it as an enterprise level, so they have their own system wherein this quantum random number generators are being tested. And the basic, as a crypto community member, I know that the die-harder is the one which which can provide you the basis, which can provide that it's a
Correct.
random.
Die-harder
Random.
is whether it is random or not.
Yeah, so that it is tested in actually. So that's the one thing that you can maintain, that you can take it as a parameter to to trust those quantum random number generators. And yes, it's very necessary that you must not trust each and every quantum random number generator that doesn't have any kind of provable things. Then it again comes to the probable random number generators. So you'll have to understand that. And yes, this is what.
So there is one more question by Professor Sure. How does one use QRNG in software, or do we require a quantum device?
Okay, so there are two things again. Thank you, Professor, for this question. Actually, so there are two things, sir, in this. So first thing is like as Samsung has come up with the quantum random number generator chip. So this chip is actually, the sole purpose of this chip is to use the quantum random number generators wherein wherever the encryption is being used. So this is the one use case, and the second is the you can use the APIs which are being provided in the form of programming languages like Node.js or maybe Java. So this is how you can fetch this quantum random number generators in your systems, and you can use that.
Okay. So similar kind of question by Prashant is, are low-cost QRNGs available for IoT devices?
So yeah, like I don't know, or I cannot answer about the pricing as such, but ID Quantic is the one that I would like to mention. It has a very good kind of range wherein you can use this kind of chips in your embedded systems or embedded products, and that's actually enterprise level it's applicable. So that's the one thing that you'll have to check with the vendors, and it is totally vendor dependent how they have used or how they have managed to build this kind of hardwares that are needed to be integrated in the IoTs.
So there is one really nice question, is any specific research area where scholars can concentrate?
Okay. So when we so I want to justify this question, like do you want to ask more into quantum cryptography, or you want to be focused on quantum random number generators? So when we talk about the quantum cryptography, so actually there are many researchers who are actually working die hard on this to come up with the solutions which can provide you the post quantum safe security. And when we talk about quantum random number generations, so that's actually in the phase, and it's already into enterprises, and many enterprises are actually working in this. You'll need to focus your research more on the quantum cryptographic algorithms. To mention more about this, you can focus more on NTRU, its optimization. And there is one more algorithm that I've recently heard about is Mac Alice. So it actually uses large keys, and that's the where quantum cryptography researchers are also working in. And you must work on this research part wherein this algorithms proves to be secure in the post quantum world.
Correct. So it's up to the researchers and the scholars like what is their interest is also. So
Yeah, exactly.
that is very important area. If I'll suggest that you work on a cryptography and somebody is not interested, then it's difficult. Yeah, but thank you very
Right.
much for the inputs. There is one more question. I mean, there are a lot of, we are getting like, it's a flooded with the questions and it's such a hot
Shravani,
area. So we'll, I don't
so
know whether, so would you like to
Shravani,
continue a bit or on your,
so Shravani, can we do one thing? I just have a one slide after this, and maybe we can continue for a more few minutes to the
sure,
question.
sure. Yeah.
Okay, okay, cool. Yeah. So now again coming down to this product that we are building. So there's a last thing that we prove to be a GDPR compliant product in the market. So when we talk about this GDPR compliant product, so we talk more about the personal data protection bill that METI came up with recently in 2019. So there are many privacy policies that we need to follow when we talk about creating a product or make in India product. So we must be we must have some compliances that goes on with the national security policies. This is the one thing that we follow. The next thing is the NIST. As a crypto community, we might be everyone might be knowing about the NIST policies that we come up with, and NIST is the most important and followed internationally for the for the cryptographic usage or any kind of technical usage. They have their own standards, and we maintain that as a cryptographer. So NIST specifically gives you the ability of to know about what the principle of least privilege is. So talking about this, okay, so I'll talk it about later. Then next comes is the Indian IT Act 2000. So this IT Act, this gives you sense of like when in the situation there comes a cybercrime situation wherein if your application is being used for any cybercrime, so there has to be a compliance or there has to be a provision wherein you can help out this judiciary systems to to identify the crimes and to let know what has been happened. So this is what we are doing actually, and this is what we are totally focused on. So when we talk about the privacy policies or when we talk about the personal data protection bill in 2019, we talk much more about the privacy by design policies. So these design policies are, each user has a right to maintain his or to keep his private or keep his privacy up to him or up to her. So this is what we are, we are focusing on in this kind of application. Second is the transparency in processing of personal data. So you must have this provision that wherein you let the user know and keep it towards you that what kind of the data you are using to process the data of users. So you'll have to know them that what kind of data we are using. The maintenance of the records, that's a very basic thing that each and every organization does. And next comes is right to confirmation and access. So even as I said that it's we come up with the uncontrolled data. So the users must have this ability, that they must have ability to confirm and get the access. So confirmation is regarding like there must be a confirmation about accessing whatever the information we are accessing as a product owner and as a product user for the users. The last thing we come up with is the right to correction and erasure. So if they want this data to be erased, so it has to be erased. You are no one to kind of keep on holding their data for a long time and for a long period. So that's a problem where current messengers fail. And now coming down to principle of least privilege, this application is totally configurable kind of a product wherein the user can configure it. But even if you configure it, we make it sure that your access is not minimized or your access is not taken away, because right to privacy is your thing. So if you want to share, you share. If you don't want to share, that's fine thing with us. So this is what the policies we follow in this kind of application. And as I said about the cyber crimes that keeps happening and that will keep happening. So there has to be a provision wherein you can help the judiciary systems or security agencies to get this knowledge about how these things are getting managed or getting theft or getting broken. between. So this is the GDPR compliant product that we are totally building.
So yeah, as you are a cyber law student also, so I think you know you can yeah, it's really good information about all this. So yeah.
Yeah, we can go towards the questions maybe if you.
Oh yes, thank you so much. So there is a question by Abhilash. Qubit is just representation of a state of something, but can represent multiple bits as a function of superposition. So how does quantum basis provide more randomness or true entropy, as it may still represent something in the physical world?
Okay, so when we talk about quantum random generation, and as I talked about the traditional ways or the ways that we are adopting today, even that is true random number generators or pseudo random generators. So they have the they have some classical mathematical background to generate this kind of quantum random number generations. And now coming down to this question, when we talk about the qubits in the quantum world, so these qubits are these are natural things. You cannot control these qubits, like how these qubits has to trigger or how this photon sensors or light has to send emit out. So this is uncontrollable thing that comes up in the quantum computer, and that itself tells you the probability of the randomness, and that's how the random numbers can be generated in these systems.
Oh, great. So there is one more question by Kamal. How does the application message me, which uses a script for messaging, then how does the security agency tackle with the anti-national activities?
Sorry, come again. The voice is breaking. Sorry.
Okay. How does the application message me, which uses a script for messaging, then how does the security agency tackle with the anti-national activities?
So yeah, so when we talk about this, anti-national agencies or spy agencies, which we talk about. So when it comes to the password hashing, so this is a sensitive data that we have, the script that is being used for the password hashing. So when it comes to anti agencies, whatever we talk about, or we talk about the spy agencies, so these agencies have their own functionality or memoranda to work on. And if you want to help these organizations in any kind of situations, there has to be a legal process in this when using a script. So this is the basic thing, that we don't want any kind of sensitive information to be given in any kind of hands. So we don't help each and every individual or organizations to get access to each and every data of the users. That's not actually possible even for us being an organization and being a product owner. So a script is generally used, as it is a machine hard, or maybe you can say memory hard hashing algorithm. It is generally used for so that we cannot retain this. So even in the case of helping out any organizations, we are not supposed to help in getting each and every data. Sorry, that's not possible.
So there is one more question, Bhimesh, is how are you going to handle the encryption part when atoms can be used to break the system? I mean, traditional encryption is useless when quantum computing is used to break it. Please advise.
So when we talk about this encryption algorithm, as I already said, that researchers are still working and professors are still working on the this quantum proof solutions for the encryptions that are already quantum encryptions, like NTRU and MAC Alice. So these are still in the phase of research. This is a matter of research for research students and scholars. So whatever we talk about quantum encryption algorithms, so maybe till the quantum computers will be available maybe later than to 2030 or 2035. Till then, maybe let's hope for the best to that researchers come up with such kind of encryption algorithms like NTRU and MAC Alice, which uses a longer key generations. And these are basically quantum resistant encryption algorithms that uses the quantum physics as its part. So maybe that algorithms, if it comes soon, then maybe that's a breakthrough to all the encryptions that are being used.
Right. So there is one more question by Professor Sure. Is there a notion of PRNG in quantum?
Sorry.
the notion of PRNG in quantum, pseudo random generator in quantum.
So I didn't understand the notion of PRNG. Like,
that's what the question is.
If
okay, so
certain
cryptography requires a PRNG which is key dependent. How do we how do we have such a facility in quantum?
Like to generate the quantum keys?
Right.
I didn't. Okay, so when we talk about the key generation process, so that is what actually we talked in the latter few slides earlier, that when we talk about this key generation process, so this actually works on the qubits, which qubits are later on, typecasted or maybe, transformed into the into the hexadecimal data, and which provides you the keys for, using this kind of encryptions in your current encryption schemes.
Okay, so there is one more question. Hello, Kanak, good evening. What are the, by Pranav, what are the resources so that we get to implement or understand the quantum cryptography?
So when we talk about resources, like you want the things to learn, if it is so, then internet is the greatest source wherein you can start learning about the quantum computing. And as I said, there are couple of books for the developers particularly focused on quantum computing. So you can get practical quantum cryptography. That is a book which is available in market. Second thing is that I provided to Savan, as you can start with IBM Qiskit, and you can start learning how this quantum circuits are being built to analyze the data and to perform any kind of encryptions.
So there is a question by Mayank. It is good to see Indian organization working in a niche area like this. Are there any global enterprise working on the same idea which can be a base for comparison?
Not in this itself. So not in this kind of product, but we have our own startup that I know it's in Chennai, Quantico. It's a Quantico, I guess. So that's working in pure quantum cryptography in the sense of artificial intelligence. So they are also working in the quantum scenario, or in the quantum technology, with addition to the artificial intelligence, making it more performance efficient, and in the part of secrecy, and in the part of strength.
Thank you. So there is a question by Saurabh. Hi, thank you for arranging great session on a quantum computing. I just want to ask, will quantum cryptography affect feasibility or increase the overload on the system?
Okay. So when we talk about this feasibility, so as I already mentioned, that when the quantum computers come into public usage, and when this kind of quantum things comes into public picture, so there has to be a certain change in the classical computers that we use, because obviously that when we use this kind of APIs, or when we use virtually the quantum computers for getting the results, there has to be a tremendous power in these systems to fetch this kind of results that are being generated by quantum computers. So it will not actually just take away the classical computers, but the architecture surely has to be changed a bit.
Okay, so Mr. Kamal wants to ask, my question was how your company can help Government of India, Police, NIA doing investigation and courts for prosecuting offenders.
So yeah, like as I clearly mentioned about this, the process is very clear, that we follow the public procedures that are being used by the government, and this is where we win. The thing is that whenever the things like any cybercrime happens, say in the sense of military, in the sense of police, or in the cybercrime areas, so we are liable to take this as a legal process, rather, wherein we can help them to get up to that certain user, and not to the exact data of it, but to the user who has created such kind of a cybercrime, or who has initiated this cybercrime in this using this application. So this is how we will help each and every organizations.
So there is one more question: how to ensure data is not even accessed by backend application team managing the system?
So the thing is, like, whatever encryptions that we do, whatever encryptions that are being stored or being used by these
Hello?
or how we let you know is that we have certain policies even to to enter this kind of systems and to enter and to get some kind of information out of this. The second thing comes up in this is as this information is totally encrypted format, there are various things that we have as in our organizations. There are some standards that we follow, that an organization follows to use any kind of information only in the sense of legalities, and when there is a need to go into the legal procedures. So we don't have any provisions to just enter this kind of data. We can enter it only in the legalities stage.
Okay, great. So I think there are a lot of questions, and I think this is a really, really nice session, I must say that.
Yeah.
Yeah,
Maybe what we can do is maybe we can take a couple of questions, and then I'll be glad to answer all those questions on my mail if I get it.
yeah. So almost all the questions you have answered, and yeah, so I think not much question has left. We have
Okay.
already, so yeah, there is one more question. Okay. So they are asking about the certification. So there is no certification, sorry, sir, for this webinar. So thank you so much, Kanak. I mean, it's a really, really nice session, and it's thank you for your time, your valuable information about quantum cryptography and secure messaging schemes. I'm sure that our researchers are working hard to make India
Yeah.
Atmanirbhar, and we
Yes.
can say that soon India will become the Atmanirbhar.
Yeah, sure. And
And
yeah, I would like
like
to thank DSCI to hosting me for this webinar. And I was equally very much excited to have this session and to have a conversation with the crypto community that has joined.
correct.
And I have got a lot of many questions in this, and it's something like people are really interested to work in this field, and they are actually getting connected to this world, which talks about some post-quantum world.
Yeah, correct. I mean, it's like very hot topic, and everybody wants to
Yeah,
know about it. And really, thank you so much. I'm
yeah.
sure all attendees must be contented with this discussion. Dear attendees, thank you so much for being wonderful audience. Thank you for your great questions. We will come up with more such exciting innovations in the next episode. So stay tuned. Until next time, stay safe, stay secure. This is Shravani signing off. Bye bye.
Thank you, Shravani. Thank you, dear. Thank you. Jai Hind.